we know that females are born with two X chromosomes and males are born with an X and a Y. So since females have twice as many X chromosomes as males, we look at the Lyon hypothesis to sort of make sense of why it is that biological females don't have twice as many genes or chromosomes as males. Um, so in the Lyon's hypothesis, what happens basically is that in a person that has more than one X chromosome, about half of those chromosomes are going to be randomly turned off um, in the development of the cell. So when that happens, they are turned off permanently. They don't show up like in your traits. They aren't passed down to more cells. So essentially what happens to that one cell is it goes to the edge of the cell. I'll show you this little picture. So in males, you have like a cell that looks more like this. In females, you have this really tightly compacted little area. That area is called a bar body. So it is that inactivated, that X inactivated chromosome. So we have a yellow short-haired female that we're crossing with a black male that's heterozygous for long hair. So since they're yellow, we know that they have X little b, X little b. Since they're short hair, we know it's going to be two little h's since it is a recessive trait. So the black male, we know that since he's a male, he's going to have one X chromosome, one Y chromosome, and the X chromosome is going to have a big D on it. And then since he is heterozygous and has long hair, we know that he's going to have one big H and one little h, since heterozygous means one of each. So we're going to make two little diagrams to figure out the probability for the outcomes. So we have X big B, X little b, X little by. Each of those is going to have half of a chance. And then in the autosomal diagram, we have big H, little h, and then H, little h, little h, little h, little h. Each of those is going to have one half. So when we go to make the branch to figure out exactly what the possibilities are for each phenotype, we have one half X big B, X little b, one half X little by. Each of those is going to have half of a chance to have big H, little h, or little h, little h. So to figure out those probabilities, you have to go through the branch diagram and multiply the one half and the one half. So on the top one, you're going to have X big B, X little b, big H, little h, and that's 1/4 of the chance. And that's going to be a tortoiseshell long-haired female cat. On the next one, you're going to have X big B, X little b, little h, and that's again 1/4, and that's going to be a tortoiseshell short-haired female. And then you have 1/4 of a chance for X little by, big H, small h. That's going to be a yellow long-haired male. And then you have 1/4 of a chance for X little by, HH, yellow short-haired male. So in this case, when you're looking at the tortoiseshell cats, we do know that not every single one of them is going to look the same, because as you remember from talking about the Lyon's hypothesis, 50% of the X chromosomes with the females are going to be randomly inactivated. So they are going to have different patterns.